Okay, Jalea. Ay, unsa man pag-pronounce Jayalea or Jalea? Jalea. Okay, Jalea. Wala si ano. Ornally. Okay, go, Jalea. Share me more about bond energy and bond length. Mm-mm. Then, what about ano, the bond? Is it strong or weak? Okay. All right. So, who has a stronger bond energy? Double bond, single bond. Okay. And who has a stronger bond? Double bond, triple bond. Okay. And who has the shorter length among the three? Single, double, triple. Okay. So, what's the bond order if we have three? If we have triple bond? Three. Okay. So again, what is bond order?
The number of
Muna siyang
quantum,
kuan, ma'am,
the number of
number pair.
electron pairs.
Okay, so number of electron pairs being shared by given pair of atoms. Okay, so what about if we break a bond? Is it an endothermic or exothermic reaction? If we break a bond?
Marag in endothermic manguro ma'am.
Okay, if we break a bond, we absorb energy. So that is endothermic reaction. That's why we have positive or negative sign. Okay, what about
Positive
if,
ma'am.
all right. So now, who breaks, okay, usually who breaks the bond, the reactant or the product?
The, the product.
Nag-break siya og bond dira sa product.
Ay,
Basically, it's the reactant. The reactant will break the bond to form new one. Okay, which will be the product. So, ang reactant mo ito magputol-putol, mag-break sa ilang bond in order to form a new product or to form new bonds. So, that is the product. So, the product will form the bonds. Okay, so that's why we have negative. Is it endothermic or exothermic reaction? The product.
exothermic.
Okay, if we form a bond, then that will be an exothermic reaction. Okay. Okay, so how do we calculate the total the total bond energy for a reaction. Okay. Hello, how do we calculate the total bond energy for a reaction? Merly, na Merly, ikaw mo ginadiri o makitan yun ka. Okay. John Lloyd.
Ma'am, ma'am, to calculate the energy sa reactant mo na.
Total energy of the reaction. Huh? Get help?
Energy of the reaction is na i-add siya together. First, ma'am, is i-add nyo together ang mga bond energies, ma'am, from all the bonds in the reactants. So, una siya ang one, ma'am, katong energy in. Tapos, one, ma'am, next, ma'am, is i-add nimo together ang mga bond energies for all the one, ma'am, katong bond sa products, ma'am. So, mato siya ang katong energy out.
Okay.
Tapos, one, ma'am, imong i-calculate ang katong energy change. So energy in, ma'am, tapos minus nimo sa energy out. Ano siya ang result sa katong pan.
Okay, all right. Thank you. So that is ihang gibalin no. Then he uses minus. Okay. Pwede ra pod if energy in energy out plus energy in. Oh, energy in plus energy out. Okay. So energy in, is that endothermic or exothermic? Okay. All right. Okay. 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 So thank you, John Lloyd. Now we have also talked about, okay, when do we have a polar covalent compound? When can we have a polar covalent
Higher
compound?
than 7, ma'am.
Okay, unsa to?
Higher than 7.
7?
Polarity.
7 na, the 7 na polarity. I think you're talking about pH level. Okay, unsa pa?
If higher than 4,
Point 4, higher than point 4. Ano, less than or equal to 1.7, iyang electronegativity value. Okay, so you have that one. Now, thank you so much. We are done. So let's go to, so don't forget these things. Now, this time we are going to have our lesson proper, which is on lesson 4, the shapes of molecules. So we will be depicting, the subtopics are depicting molecules and ions with Lewis structures, valence shell or the whisper theory. Then we have the molecular shape and polarity. So we have steps, okay, steps in converting formula into a Lewis structure. Okay, So steps in converting a molecular formula into Lewis structure. Okay, so if we have um, CCl4, okay, CCl4. So how do we write CCl4 or chloroform in a structure? First, place atom with lowest electronegativity in center. Okay, so between the two atoms, C and Cl, who has lower electronegativity? Who has lower electronegativity?
Ang CL, ma'am.
Cl. Ah, what happened?
Ang
What happened?
carbon na yun.
All right, we have the carbon. Because as you go across, so electronegativity increases. Okay, so we have Cl has lower electronegativity, so let's write Cl at the center. Okay, we have the C. Oh, the C has lower electronegativity, so let's write C at the center. Then okay, add a group numbers. Atom placement, throw single bond, subtract for each bond, give each. Okay, then A group numbers. Okay, so this time also let's add the okay, the other atoms. Okay, so we have the Cl, the Cl, Cl, and we have Cl. Now this time, how many valence electrons does your carbon has? We have four. One, two, three, and four. So each sides needs electrons. So that's why ato din siyang distribute imong Cl. Now Cl has how many valence electrons?
7.
Okay, we have seven. So this will be shared, and this will be shared forming one bond. Then we have one, two, three, four, five. Oh, God. Okay, so we have seven. So we have also one, two, three, four, five, six, seven. One, two, three, four, five, six, and seven. So forming one bond, and then we have one bond. So in order to check if your answer is correct, is we will calculate the number of valence electrons. Now, for C, for carbon, we have how many valence electrons? We have four. Then we only have one atom of carbon times one, that is equal to four valence electrons. Now for Cl, we have how many valence electrons for Cl?
7, ma'am.
Okay, we have seven. Now how many atoms of Cl? Times 4, that is equal to 28 valence electrons. Okay, so if you add these two, we will have 32 valence electrons. Now if we are going to check, let's check how many electrons. So let's count. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 2, 3, 4, 25, 26, 27, 28, 29, 30, 31, 32. So, you are now confident that this structure is correct because you have 32 valence electrons, and if you are going to count how many electrons, then you have 32. Okay, here also, if we have NF3, now NF3 among the two, between the two atoms who has lower electronegativity.
The N, ma'am.
Okay, so N. Now, we know that N has how many valence electrons? Bilang.
5, ma'am.
Okay, then we have 5. Okay, 5 valence electrons, and then we have, so and we have 3F. Okay, so let's distribute the F. 1 F, and then we have F here. Okay, so what is the valence electrons for fluorine?
7, yapon, ma'am.
3, 4, 5, 6, and 7. 1, 2, 3, 4, 5, 6, 7. Wrong na akong pagbutang. 1, 2, 3, 4, 5, 6, 7. Okay, so this will form a bond, and a bond. Okay, so let's check if this is correct. Now we have, so what is the valence electrons of nitrogen? We have 5 times 1 because we only have one atom. Now 5. Then what about fluorine? We have 3 fluorine atoms which has valence electrons of 7. That is 21. Then we have 28. So let's check. Let's count if you have 28 electrons. You have, ipa ninyo, correct na?
Yes, ma'am.
Okay, so that is correct. Okay, thank you. Okay, so now, okay, so here. So write the Lewis structure of HCN. We have HCN. Huh. Okay, we have HCN. So, who has the lowest electronegativity value?
Ang H, ma'am.
Yes, actually it's the H, but we cannot put H as central atom or ibutang na to siya sa center because he has H has only one valence electron. It means that it can only bond to one atom. Then we have two atoms needed to bond para maka-form. So we cannot put H at the center. So between C and N na lang atong option. Remember, bisan asa jud na mabutang si H, di na siya mabuhat na central atom. C and N, who has lower electronegativity?
C, ma'am.
Okay, we have
Carbon, ma'am.
all right. Yes, it's the carbon has lower electronegativity than your N. Okay, so we have, oh, sa to, tara. So you have your carbon. Then what about your N? So let's write that one. We can have H also here. Now, Okay, so how many valence electrons does your carbon has?
Four, ma'am.
4.
Four, ma'am.
Okay, ato ibutang na lang na siya. For carbon, we have 4 times 1, that is 4. And then N. What about your, okay, 1, 2, 3, 4. What about your nitrogen?
5.
1,
Five, ma'am.
2, 3, 4, and 5. So we have 5 times 1, that is 5. Then what about your hydrogen?
One.
1 times 1, that is equal to 1 electron, valence electrons. Tamutahan na lang ako do V ha. Okay, so that is a total of 10 valence. Yes, 10 valence electrons. That's how many? So we have that one. Now, H and C can form a single bond. So carbon, this electron here and the electron from nitrogen can also form a single bond. Okay. So are we done? Now,
Makuan siya, ma'am. Triple band siya, ma'am.
okay. Why man?
Kay, kuan na, ma'am. Ang kulang na electrons na MP, di ba, 8 yun ang makuan ni ma'am. Kay, ang electron ni C, mura siya ma-share sa N, ma'am. So, ma-complete na to ang iyang kuan sa shell, ma'am. Kung 8 electrons sa shell.
Okay, thank you so much. But also, if kanilang ang atong tanawon sa when we are just counting the valence electrons, na-achieve na ba niya that we have 10 valence electrons? Let's count. How many electrons? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 valence electrons. Achieve na no? Correct na. So will we stop there? Another also that we are going to take note is the katunggiingon ni Dexter, which is the octet rule. Now let's check if the central atom has achieved octet rule. Has it achieved? Now, how? Okay, pila ra ihang electrons? 6 only. And then also, so, ug makita man sa nimo na ay naapay daghang mga electrons nga ga-float. These electrons are very reactive. So they will always find ways to react to another atom. Okay. To the electrons of another atom. Okay. So this electron and these electrons, they will form a bond. Okay. And these electrons too. Okay, kini sila mag-share pud silang duha. Will be shared also here, forming a bond. So we have the final structure is we have lone pair. Okay, HCN. Now let's count if ano gihapon if it has follows this 10 valence electrons. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons. Okay, so if you have, if first thing is you will check there are, uh, if there are correct number of valence electrons from your solution. And then also the second thing is you will check if it has achieved octet rule. Now, carbon has already in this structure, carbon has achieved octet rule, and even the nitrogen also. Okay. Then, if you have unpaired electrons from each atoms, then you can pair them up. You can pair them up, forming another bond. Okay, just take note of that. So we will not only stop by having only single bond. Now, if we can see that, oh, there are unpaired electrons, there are still unpaired electrons. So these electrons are very reactive. They will always find ways to react with another electrons from another atom. So that's why they will, we have no choice but form another bond because they will always do that. So bisan pigilan na nimo na sila, di nimo sila ikuan, i-react then. Marong nanon ka. Okay, so we have that one. So, i-pair gid nimo tanang electrons. Okay, so we have, all right. Okay, if we have CClF2. Now, so we have three different atoms. Okay, so central atom we will have
Carbon.
carbon, and then we will just distribute the four atoms. We have Cl here or Cl here or F here and then F here. So we can do that one. Then, okay, so forming a bond, a bond, a bond, and a bond. Okay, we know that this has 8, 8 times 8, 8 times 4, that is 32. So, okay, so we'll have 32 valence electrons, 1 times 4 for carbon, plus 2 times 7 for fluorine, and 2 times 7 for chlorine. So that is 32 valence electrons. So if we are going to count, then each electrons, okay, then we will have 32 valence electrons. Okay. Now, since no unpaired electron left, then we can ano we can think that we are partly correct. Then after that one, we will check if each atoms has achieved octet rule. Okay, so we have also, now what about these electrons, ma'am? Okay, ma'am, ato na silang i-bond. Dili taganhan naman na sila dira, ma'am. Unsa man nato na sila? Pwede pa nato siya i-bond to another electrons? This one? Kana electrons nga nasa oxygen. Pwede? Pwede? Okay. All right, so let's count how many valence electrons for oxygen. 1. How many valence electrons for oxygen? Okay, 6. All right. We have one electron from this side and then one electron from this side, leaving us with how many lone pairs? Two lone pairs. Okay. We have that one. Thank you. So, if there are not enough electrons for the central atom to attain an octet rule, to attain an octet, a multiple bond is present. Okay, so we will, if not enough na, then there are still unpaired electrons, then we can have multiple bonds. Central atom does not have a full octet. Change a lone pair on a surrounding atom into another bonding pair to the central atom, thus forming a multiple bond. Okay, so you have that one. Okay, what about, ano man eh, daghan ni kayo. Okay, what about ethylene? C2H4. Or what about C, oh, C2H2? Diba? Okay, what about C2H2? Okay, so how do we write that one? We have carbon as the central atom. Then what else? Next to carbon, we have we can do carbon also because that's what make carbon. Okay, that's what makes carbon very special because it can do catenation. Catenation is it can pair to each other. Okay, it can pair carbon carbon. Okay, carbon carbon. So we can have that one carbon. Okay, so let's have how many valence electrons? We have four, and then we have one, two, three, and four. Okay, so this we know that. Okay, what about the H, the two H? Okay, let's put them to each side. Okay, we have them. All right, so let's pair them up. We have okay, this one and this one, a bond, and then we have a bond. Okay. Finish na? Done?
Yes, ma'am.
Mag
Dili pa, ma'am.
magbanding pa na, magbanding pa na ang mga
Mabanding pang
electrons
duha ka
uban,
carbon,
ma'am.
ma'am.
Okay, so we have that one. So, kanis lang duha. Okay, and then the two forming. Okay, so we are done. Okay, so ano ha?
Excuse me, ma'am.
Yes?
Ang carbon lang ang kuan compatible sa each other, ma'am.
No, we have also silicon.
Okay, ma'am.
Okay, silicon. But in organic chemistry, carbon is always is preferred because it is more stable than our silicon. Okay, Si. Okay. All right. Now, what about also the diatoms? We have the H2, it's diatom, the O2, the N2. Okay, 7 to sila kabuok. So we have that one. They are kani diatomic. So O, oxygen, oxygen, N2. Okay. So we have that one. Now we call this process catenation when carbon reacts to another carbon, that is catenation. Okay, let's check if all the atoms has achieved octet rule. We have the carbon, it has achieved, yes or no? Carbon 1 and carbon 2. Octet followed octet. Naka-follow silang duha? Yes or no?
Yes, ma'am.
Okay.
Papalo ra, ma'am.
All right. So we have that one. Uy, dako kayo. Okay, then we also have N2. Okay, for N2, we have how many valence electrons?
Five.
Ay, 5. 4 and 5. Okay, so how expected, we have this bond. Finish na. This bond, okay, this thing, these electrons, okay, forming 1, 2, 3. Okay, having how many lone pairs? We have 2 lone pairs. Okay, so that's it. Now we have resonance structures. We have O3, so the ozone. So O3 can be drawn in two ways. These are two different reasonable Lewis structures for the same oxygen molecule. Okay, we have structure 1 and then we have structure 2. Now cite the differences. Ozone 1 and ozone 2, structure 1, structure 2. What are the differences?
Ma'am, neither first oxygen ka magbanding or nor neither dito ka sa first to second oxygen or sa second to third oxygen.
Okay, so we have that. Okay, we have a double bond here or a double bond here. So, those two are partly correct. Okay, so now if that's the case, because nga na naabot madali ang isa ka kuan ma'am double bond because the electrons here if we have our resonance structures, the electrons are delocalized, so meaning the double bond or the electrons from this double bond can transfer to the oxygen 1, oxygen 2, okay, oxygen 2, oxygen 3. So it can transfer to the oxygen, and then because sobraan na siya, no, then it can. Okay, so it can transfer here, and the oxygen here will be electron deficient. So mo back up dahil imong oxygen 3 forming another bond. Okay, forming another bond. So if that's the case, we will have oxygen na lang. Okay. Forming the double bond will be here na dayon. Okay. Another that one. Now, if this case also the double bond, the electrons in the double bond can also transfer to the oxygen 3. Now, oxygen 3, then the oxygen here will be electron deficient, kulangan siya. So, the electrons in this oxygen 1 will transfer to here, forming a bond. So, we will have double bond na din siya. Oh, God. Okay. So, we have that one. Now, this is the resonance structure. When we say there's a resonance structures, we have same relative placement of atoms but different locations of bonding and lone electron pairs. So we have different location of your double bonds or the bonding, and also the lone pairs, because if we have this structure, then we will have three lone pairs in this oxygen, and if we have this structure, we will only have two lone pairs. So that is resonance. So we have this double-headed arrow to indicate that it is resonance. Now, when it is resonance, so the electrons are delocalized. When we say delocalized, it is spread throughout. So if it is spread throughout, okay, it is spread throughout. So it will naman siya float ra here. Float, float, float. Okay, that's why neither of these structure 1 and structure 2, wala sa ilaha ang pinaka-accurate na structure. Pinaka-accurate because the accurate structure is the average of the two. We have this structure 1 plus the structure 2 in order to have the most accurate structure of our ozone. So in that case, the most accurate is we will have, okay, oxygen, oxygen, okay, and then we have the lone pairs, no? then we will have broken dots, mga dot, dot, dot. Okay. Indicating that this indicates that the electrons are spread, okay, are delocalized in this two. So nag-spread ra, katag-katag na imong electrodes. So this means if we have that one, it means that it's a resonance structure. Resonance structure. Now, this is neither of the two are accurately correct because the most accurate structure is this one, which is the average of the two structures. Okay. So, species like O3, which can be depicted by more than one valid Lewis structure, is called resonance hybrid. Resonance are not real bonding depictions. Okay, it's not real bonding depictions. O3 does not change back and forth between its two resonance form. The real structure of resonance hybrid is we have the average of its contributing resonance forms. Okay. So, the pinaka-correct is this one. So, dotted lines are used to show the localized electrons because if we have example, if we have CCl4, oh god. Hello? Hello? Okay. All right. So we have if we have CCl4, now as you can see the bond there is real depiction and it is localized meaning naara dira sa ilahang duha ang imuhang electrons naara sa ilaha diri anira nga position diri ra nga location this bond only, but if we have the broken dots then it meaning that it is delocalized, its density is spread, its density is spread. Okay. So now also if we have this one Cl, okay. So we know that the electrons are localized in this bond only. So naara dira dapit ang imuhang electrons, just that if we have a polar covalent bonding, this one is the electrons will go to the stronger one which is Cl. So makita lang nato ang imong electron is partly in this if we have this one, so the density here will be greater than your Cl. Magna density to ba? Here, so makita na to nga, murag diri dapita mas dako nga chances nga duol sa Cl imong electron sky. This is more electronegative, so masuyupon niya ihang ihadjong i-attract kay stronger man siya. But in this case, this is delocalized, meaning it's spread. Tatatat na sila dapit tata. So this is the most accurate one structure. Okay, now for resonance hybrids, okay, often so the what will happen to the bond orders? Now if we have CCl, Cl, Cl, and Cl, so mm, 1, 2, 3. Okay, in this case, what is the bond order in if we have CCl4? What is the bond order if we have CCl4? Di ba kato ganina bond order if we have single bond, bond order 1. If we have double bond order 2.
Bond order form.
Bond order 4 because there are 4 single bonds. Now, what will happen? Okay, so if we are going to calculate using this formula, no? How many electron pairs? Okay, so if we have this for CCl4, CCl, hinaya, If we have CCl4, okay, we have equals. So how many electron pairs? One pair. Isa ka parisan, duha, four. Okay, we have four pairs. Four electron pairs. Okay. Over how many bonded atom pairs? Pila ka bonded atom pairs? Bonded atom, ganina electrons. Pila ka parisan? We have one bond atom, two, three. Oh my God. Okay, four. Four bonded atoms. So what is four? Oh, okay. Four bonded. Four. I see. So if we have four, now four. So what is the bond order? Bond order is equal to one. I see. Okay,
One.
one. Dili day siya four class. Divide po din mo siya sa divide mo sa four bonded atoms, so that is one. Okay, so that is one. Okay ha. Dili kay mag-ihap maka tag pila ka single bonds kay mao na dayon na siya because the single bonds, that is the four pairs, no, four electron pairs, i-divide pa nimo how many bonded atom pairs pa jud. Okay, so we have that one. One ihang bond order. Now, if we have resonance hybrid like O3, then we will have a fractional bond order. So in this case, how many electron pairs being shared? Or one pair, two, and three. Okay, we have three. Now, how many bonded atom pair? We have first bond. Then we have first atom, second bond atoms. Oh, okay. So we have two. 3 divided by 2, that is 1.5. Okay, so we have fractional bond orders. So fraction siya basta. Ano siya, resonance. Hello, 16 pata. Okay, so don't forget that one. So we have the, okay. Right, resonance structures for nitrate ion and O3 minus, and find the bond order. Okay, so let's first calculate how many valence electrons we have. For N, we have 5 times 1 plus. For oxygen, how many valence electrons? 6 times how many atoms? How many atoms of oxygen? 3. Okay, are we done? Not yet. We will add, what about this one? The negative charge. What does negative charge mean? It means gain or lose?
Gain.
Okay, it has gain. So it has gained how many electrons?
One, ma'am.
So, unsa siya? Plus, no plus. Okay, pero og positive po ni dire, minus po itong buhaton dire. But since it is positive, so we will add 1 electron. So how many valence electrons dapat? 24. Okay, so let's write that one. Let's write NO3. NO3 minus. We have nitrogen 1, 2, 3, 4, and 5. Then we have 3. Oxygen 1, oxygen 2, oxygen 3. So we have 6. 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, 6. Okay. Now let's bond. 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 Okay na? Naon sa asa man nato na ibutang? We have these electrons.
Ay,
1, 2.
pairing pa ang oxygen.
What do you mean by pairing? Sige, unsa na to? We will add octet na ang kuan 2. Sige. Or because it has gained 1 electron. Or we can form a double bond here. We can form the double bond losing these 2. Okay. Because we have here. So we can add a double bond either here. Because we have this electron. Okay. So mawala na ni siya. Okay. And also that 2. So forming another one also. Here, we can also lose this one because we have formed the double bond. Okay, so we have this one. Now let's count. Okay, we have this negative, we have this unpaired electron. Kita mo ani, di ba? Wa siya nato na parisan. Okay, we have this one unpaired because it's the negative. So na siya sobrang 1 electron. Okay. So we have that now. 1. So let's count if we have pila to? 24. 24 electrons. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 20, 2, 4, 6, 8, 2, 4, 6, 20, 20, 21, 22, 23. Pila ka electrons class? Please count daw. 24, Manjud. We have 2. We have 1, 2, 3, 4, 5, 6. Nawala diri. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. No, the negatives 6, 7, 8. Okay. Then if we count that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So this one. Okay. All right. So we have this one. Okay. We have. All right. So we have this structure. So the negative one, the negative sign came from here because the nitrogen, okay, nitrogen, how many, so what if we're going to count, it's the formal charge. Now formal charge, how are we going to identify the formal charge is we will count how many electrons. Thus 1, 2, 3, 4. Okay, so we'll count how many electrons does the atom has. Okay. If it has already bonded to other atoms. So let's count. We have how many electrons? We have 1 electron, 2, 3, and 4. Now we know that nitrogen has how many valence electrons?
5.
Okay. We have 5 valence electrons. So if how do we do that is we have 4 because there are 4 electrons here minus the valence electrons, that is equal to negative 1. So that's why we have the sign negative 1. Okay, what about, all right, no. What about, let's count here also because this has formal charges also. How many electrons here? 1, 2, 3, 4, 5, 6, 7. We have 7 electrons. Now, how many valence electrons does oxygen has? So, na siya ay sobra, no? So, if sobra, that is positive 1. Wait sa ha. The formal charges. Okay. 6 valence electrons minus the unshared. Okay. The valence kanina. 5 minus 4. Oh, this is positive. Okay. So, we have that 1. Baliktad eh, class. Una, the valence electrons. It's the valence electrons first. So, we have the valence electrons 6 minus 7. Minus 7. That is equal to negative 1. Here in this case, 5 minus 4. That is equal to positive 1. Now, here also, what's the charge, formal charge here? We have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 6 minus 7, that is also negative 1. Then here also the formal charge is also 1, 2, 3, 4, 5, 6. 6 minus 6, that is 0. 6 minus 6, that is equal to 0. So, take note. Okay, we have this negative 1 also yung charge here. Then here is we have positive 1. Okay, so this is more reasonable because nitrogen has lower electronegativity Then your oxygen, so if that's the case, so oxygen will always take the negative sign because it is more electronegative. So we have this one. We have -1 for the oxygen. The formal charge of oxygen is -1. Now for nitrogen, the formal charge is +1. Giun sa ganito pag-calculate class, we have, hello, giun sa ganito pag-calculate na kung ano.
-4, ma'am.
Okay, the valence electrons
Minus
minus,
electrons.
okay, minus the present electrons nga na iyahang na accommodate. Okay, so we have that one. So this is +1, and in this, the oxygen here on this side, that it has -1. Now the total form, okay, the formal charge, okay, which is usually written, we have the bracket, and then we have that one, the bracket, then we have the sign here, positive or negative. So yun sa man na siya, so this sign just came from the total formal charges of each atoms. So we have -1 plus +1, that is equal to -1 plus
0, ma'am.
+1, that is 0, plus 0,
Zero, ma'am.
plus 0.
0, ma'am.
Okay, plus -1.
-1, ma'am.
Okay, so that's why in total in your NO3, NO3 has formal charge of negative. Negative. So this negative here came from the total formal charges of each atoms. Okay? So we have that one. That's how we calculate the formal charge. Now let's go to O3. So what's the formal charge of O3? We have oxygen 1, oxygen 2, and oxygen 3. So what is the formal charge of oxygen 1? How many valence electrons? 6 minus, okay, okay. Before we do our katon trick here, we will follow this formula. We will follow this formula, okay, ha? So 6 valence electrons minus unshared valence electrons. How many unshared valence electrons? 1, 2, 3, and 4. We have 4. Okay. We have 4. 4 plus the shared 1/2 of shared valence electrons. The shared valence electrons. How many shared valence electrons? 2.
2.
We have 1 shared valence electrons. 1, 2, 3, 4. That is equal to 4. Now it says times 1/2. Times 1/2. Okay, so what is the formal charge? We have pila. 6 minus, okay, 4 plus 2. 6. 6 minus 6, that is 0. So we have 0 here. Okay, what about oxygen 2? What is the formal charge of oxygen 2? Okay, we have 6 minus how many unshared valence electrons? 2. Anong 4 man? Unshared. Valence, kanang wala gi-share ba? Tara o, 2. Okay, we have 2 plus 1/2 times shared valence electrons. 3, 4, 5, 6. Okay, how much is this? 6, 3. Okay, pila ni siya? 3 plus 2, 5. That is positive 1. So it has positive 1 here. Now, what about this one? This third oxygen. Third oxygen's valence electron is equal to 6 minus. Okay, unshared valence electrons.
6 siya.
6 plus shared valence electrons.
2 ma'am.
2
2 ma'am.
times 1 half times 1 half. Okay, so that is equal to,
Negative 1.
so we have negative 1. Now, okay, so the total formal charge will be, okay, total formal charge, the sum of all formal charges of each atoms. We have 0 plus positive 1.
0.
0 plus positive 1.
0.
Positive 1 minus 1 plus negative 1. That is equal to 0. Cancel mo yun, ha?
0.
Cancel. O, so that's why your ozone has only this structure. Okay, wala dun yung gibutang ang 0, no? So because unless written, it is always given that it is 0. So it is neutral. So it is neutral. Unlike your nitrate, it is charged. It is an ion. It has a formal charge of negative 1. Now again, negative 1 came from the total formal charges of each atoms. Okay, of each atoms. Okay? All right. So we have that one. That's how we calculate formal charge. Now, okay, I wait sa. All right. So that's how you calculate formal charge. Asa to ganina? Oh no. Nawala lagi to. Katong natin sulat-sulat sa formal charge. Okay. We have that one. So that's the formal charge of your ozone. Now, if ano ka to ganina, if we will have a trick, okay, we still have a trick on that, which is you will box each oxygen. Now, how many electrons here? We have 1, 2, 3, 4, 5, 6. Only count this one electron. That is 7 electrons for oxygen. Now, we have 6 minus 7. That is equal to,
Negative 1.
okay, negative 1. So this electron here has a charge of negative, this oxygen here has a charge of negative 1. Now, what about this one? What is the charge? So let's count how many. Okay, the valence electron is 6 minus how many electrons? 1, 2, 3, 4, 5. That is 5. So that is positive 1. Then what about this one? 1, 2, 3, 4, 5, 6. 6 minus 6, that is equal to 0. So, negative 1 plus positive 1, that is equal to 0. So, you can use also this one. You will only box the atom, then count how many electrons. Or you can use this formula, Chud, which is ano siya, mas taas-taas siya. Okay, so we have that one. Now let's go back. No, wala na to na human ug answer ni. Okay, so we have that. We have this. Okay, we have the structure of your NO3, NO3 minus, or we have the double bond here. Can you see this one? Kita? For resonance structure. Okay. Now we know that the electrons in resonance are delocalized. So delocalized meaning it's spread. So the electrons in this double bond can transfer to oxygen, and then here also to the electron pairs also here will form as a bond now, so leaving having double bond, and then also the electrons here can also form a double bond here. So we have three. Now if we have that central atom, first is we have N double bond O, then we have oxygen, then we have oxygen. So then we have to enclose that one with a bracket because it's charged -1. Then we will write the arrow, the double-headed arrow, meaning it's the resonance hybrid. So we have, again, we will enclose that one with a bracket, and then we can have the double bond on this side, then leaving single bond on, here at the bottom. Then we have single bond here. Then we have negative. Then we can have the other double bond on which side? Asa to mabutang isa ka double bond, class?
Left side lang.
Okay, so this one. So these are the three resonance structures of your NO3, and we can write that one, or if no need na ka magbuhat-buhat three structures, then you will just take note of this one. And oxygen, oxygen, then we have oxygen, then having the dot 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 dot. Okay, the dot 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 dot, meaning we can find the electrons here. So it is spread, it is delocalized. Now let's calculate the bond order. Okay, bond order. So isa lang ka structure atong kuag bond order kay pareha ra man na sila tanan. Okay, bond order, the formula of bond order is we have asa tong bond order. Okay, bond order is how many electron pairs? Electron pairs over bonded atom pairs. Electron pairs. How many electron pairs? Okay, how in this ano ha kani nga atong kuan kanina structure. Structure 3. So how many electron pairs? We have electron 1, 2, 1, 2, 3, and 4. We have 4 electron pairs. Okay, 4 electron pairs divided by bonded atom pairs. How many bonded atom pairs? NO bond. 2, 3. We have 3 bond atoms. Bond atom pairs. Okay, so that is equal to BO is equal to 4 divided by 3. So that is equal to 1. 4 divided by 3, that is 1. 1 divided by 3, 3. 1 and 1/3. 1 and 1/3. So the bond order for this is we have 1 and 1/3. So as you can see, it is fraction because that is for resonance hybrids. Always fraction. Okay na? Alright. Oh God. So we have formal charges. Okay, we have calculated already that one. Choosing the more important resonance form, smaller formal charges or positive or negative are preferable to larger ones. Okay, same non-zero formal charges on adjacent atoms are not preferred. Avoid liking charges on adjacent atoms. A more negative formal charge should reside on a more electronegative atom. Okay. All right. So here, NO3. Okay, let's have this example na lang kani. Okay. So, we have NCO minus. So it has possible three resonance forms. We have structure 1, structure 2, and structure 3. Now, if we are going to identify, we know that NCO, that the most accurate structure is the average. We know, diba? For resonance structures, neither of the two structures or three structures are most correct because the most accurate one is the average of the three. So ipang plus plus na nimo sila, meaning the structure 1 has contributed to the correct or to the accurate structure, then structure 2 also has contributed to the most accurate structure, and structure 3 also has contributed to the most accurate structure. However, however, so silang tulo nun ay contribution because again, it's the average. However, the murag level ba, ang percent nga ihang gihatag na structure nga contribution to the most accurate one is nagdepende. Now, we have to identify the three structures to identify who has given or who has contributed most. Okay. So, kinsa man ang kanang murag pinaka-correct nila batanan. Okay. So, we have, now first is we will identify the formal charges. Now, if we have N here, the nitrogen here has what is the formal charge of nitrogen here? We have 5 minus 1, 2, 3, 4, 5, 6, 7. That is equal to positive 2. Hello, maklaro pa ko? What about the carbon here? What is the formal charge of carbon here? Carbon has 4 valence electrons minus. Okay. Naka-follow ra gyud sa nako pag minus. We have 1, 2, 3, 4. 4 electrons. So that is equal to 0. So we have 0. Now what about the oxygen here? Oxygen has how many valence electrons? 6 minus 1, 2, 3, 4, 5. Minus 5. 1, 2, 3, 4, 5. 6 minus 5. That is equal to okay, 1, 2, 3, 4, 5. Okay, 2, 4, 6, 8. Sakto man. Okay. We have we have 1 electron, 2, 3, 4, and 5. So that is equal to positive 1. Positive 1. Pay nako. Okay, positive 1 siya. 1, 2, 3, 4, 5, 6. 6 ang valence electron, no?
Yes, ma'am.
Ay, nabalipad siya ta. Ay, okay.
N sad lang.
Na N sad no sa N. So, dapat dili valence okay. So, dapat ang formula is dili valence electrons minus katong electrons nga occupied sa iyang atom. Dapat ang atom pila ka buok then usa minusan sa iyang valence electrons. No? Palit na po.
Yes, ma'am.
Oh, okay. Sorry, class. Alright. It's a kanila. So, we will have 7 minus 5. That will be positive 2. Oh, baliktad siya dahil. So, first is how many electrons first, and then how many minus the valence. That will be positive 2. Now, in this case also, in the oxygen 3 also, in third atom, the oxygen, so we have dapat 1, 2, 3, 4, 5. The minus the valence, that is equal to negative 1. Okay, sakto no? Alright, we have that one. Okay, now what about this one? Let's check also here. We have 1, 2, 3, 4, 5, 6. So 6 minus 5, that is equal to negative 1. This 1, that's 4, that is 0. This 1, this is 1, 2, 3, 4, 5, 6. 6 minus 6, that is also 0. Here also we have the nitrogen, that is 1, 2, 3, 4, 5. So 5 minus 5, that is 0. Here, 4. 4 minus 4, 0. Hello, nakafollow pa? 1, 2, 3, 4, 5, 6, 7. So 7 minus 6, that is negative 1. Okay, follow pa? Hello? Question.
Yes, ma'am.
Do you have questions? Sige, pag question, I expect questions. Rian, question. Kenneth.
Excuse me, ma'am.
Oo.
Ma-
Yes.
Valence, ma'am.
Ha? Unsaon pag?
Define sa valence.
Unsaon pag define? Unsaon pag identify sa valence?
Yes, ma'am.
Okay, sige, good thing. No, kay sige ratag kuan og valence. Okay, so valence electrons are the electrons in the outermost electron shell or atomic shell. Katong shell bang katong ana-ana ba? Ay, goodness. Wait sa ha. Katong shell. The nucleus, then we have the first orbital or the energy level 1. Then we also have energy level 2, energy level 3, energy level 4. Now, also it has subshells. We have S, mag-ana na ba? S, P, D, F. Okay, it has that one. Now, when we have valence electrons, katutong electrons pinakalayo. Pinakalayo. Now, if pinakalayo ka, nara ang nucleus. Now, if ikaw ang pinakalayo, then, gamay ra imuhang attraction sa nucleus o ikaw. Tending that, you og naay other reactions, tending that if there are other electrons here, electrons from other atoms, okay, from other atoms, you tend to be removed, especially if kay ikaw man ang pinaka-weak sa ila or gamay ra man imong energy nga attach sa inyong duha sa nucleus. So ikaw easy kay ka ma-remove forming or bonding to this other electron. So ikaw ang valence electron. The valence electrons are the outer electrons. Now, they are the electrons most easier to remove. So also, the valence electrons are also responsible for chemical reactions for forming another bonds because easy naman ka ma-remove like here in this case. Now, how do we identify the valence electrons? Okay, the valence electrons is we have ano lang jud siya, trick lang ni siya. We have one and all these elements has one valence electrons, and this all this element in this group has two valence electrons. Now all this element has three valence electrons. This one four, and they have five, six, seven, and eight. Okay, so mao na siya. Now, if we have oxygen, if it has six valence electrons, that's why we write oxygen one. There are six valence electrons. Six man daw. Kay narao, ika-six siya. So we have one, two, three, right, three, four, five, and six. So if it has six valence electrons, now we know that atoms react to other atoms or to each other in order to achieve to become stable, and in order to have the same electron with the no, noble gases, which is in 8 group 8. Group 8 mao ni sila ang noble gases. Now they are very stable, og sa mga tawo pa sila ang standard sa imuhang mga atoms. Okay, sila ang standard. Ay, ganahan ko parehas mig electrons ni helium, ni neon, ni argon, ni krypton, ni xenon. Kay sila ang standard. They are very stable. So that's why if we have oxygen, because it aside from that, it has noble gases has achieved octet. Okay, octet rule. Now, octet rule dapat an atom must have an atom to become stable. It must have 8 electrons, 8 outer electrons. Dapat we have oxygen. Dapat imong oxygen kay 1, 2, 3, 4, 5, 6, 7, 8. Dapat kaniyahang ma-achieve to become stable. Now here, oxygen, first, unbonded oxygen is only have 6 valence electrons. So, unsa iyahang buhaton para makabuhat siya 8 electrons or maka-gain siya 8 electrons. So it will react with other atom. So in this case, he has to react with other atom and he has to share, okay? Pwede share or pwede po siya i-transfer nga mapudan siya og duha. Kay 6 ra man na, 6. Pila may kulang sa 6 para mahimong 8? 2. So these two nga mga walay pares kayong duha kinahanglan na sila to gain, they will gain another electrons. 2 electrons para mahimong 8. Now, if we have fluorine, how many electrons iyahang kinahanglan? 1. Okay. So, all in this side, they gain, or non-metals, they gain electrons. They gain because ano pud no more pud og sa sa tao lang jud pud sa life. If other gain, then someone has to lose. Okay, if other gain, then someone had lost. So we have this one. So these metals lose electrons. Okay. So because pila ang valence electrons sa imuhang sodium? it has only, okay, sodium has only one. So, maura jud na iya ha, one. Nya, pili kinahanglanon, it has to achieve octet. Dapat 8. Hala, unsa man iyang buhaton sa sodium? So, pilay kinahanglanon sa sodium? Okay, 7. But, dako kayo ang 7 nga wala niya. Wala siya ng 7. So, iyang buhaton is, oh, ako na lang ni ilus akong isa ka buok. Ako na lang ning ilus ni akong isa to achieve octet. Kay kuan man na niya, react man niya with other atoms. So ako na lang ning ilus ni ako isa. I cannot gain 7. Daghan kayo na asa man kung manguhaan na. So ilus na lang nako ning isa to to achieve octet. Now, that's why the metals loses electrons. Then we have the strontium also. Strontium has how many valence electrons? 2. So he has to lose gihapon, he has to lose 2 electrons uh to become to become or to have the same electrons with, okay, if we have strontium, to have the same electron with Kr. So this is Kr. So ihan na lang ng ilus. Kay if he will gain 6 electrons, that's too many electrons para lang jud maabot siya sa xenon. Oh, I cannot, dili man nako kaya. So what I will do is I will lose to have to become isoelectronic with krypton. So again, the noble gases are their standard. So aside from that, they will also achieve octet rule, and to become isoelectronic, when we say isoelectronic, they have the same electrons with krypton. Okay, if we have calcium, how many electrons does calcium have? What's the atomic number of calcium? O, ang atomic number sa calcium, okay, makita diri sa babaw na siya, nimo makita kanina ni. Hey, na-circle-circulan na siya. We have 20. So, unsay buhaton sa imuhang calcium? Will he gain or lose? Oh, he will lose the 2 valence electrons niya. He will lose the 2 valence electrons to become isoelectronic with argon. Okay, to become isoelectronic with argon. Kay, as you can see here, 20 minus 2, kay imo ilus ang duha, that will be 18. And that is argon. 18 kay ang argon. So the calcium has to lose 2 electrons to become isoelectronic with argon. He cannot gain 6 electrons just to become isoelectronic with krypton. Dili mahitabo. Because taas kay siya glabangon nun, especially that he will pass pagali sa d orbitals. Okay. So all the metals lose and all the non-metals gain. Now, the valence electrons are the outer electrons. Now, if in the periodic table, makita ra siya nimo, we have 1, 2, 3, 4, 5, 6, and 7. Now, in the case of carbon, ano no, naana siya sa tunga, it has 4. Carbon has 4 valence electrons. 4. So, unsay ang buhaton? Mura siya, pwede siya mo lose or pwede po siya mo gain. But, carbon prefers to lose because it's not, prefers to gain because she is, non-metal. So, he will gain 4 electrons to become isoelectronic with 1, 2, 3, and 4 to become isoelectronic with neon. Now, the phosphorus, how many electrons must he gain? Pila yang i-gain? Pila again sa imong phosphorus? Tarang phosphorus. 3. 1. Okay. To become isoelectronic with. Okay, very good. So we have 3. If we have the atomic number of phosphorus, that is equal to 15. Now, if we add plus 3, okay, so that will be 18. Ang 18 is argon. So, ang imuhang non-metal is they will gain electrons to become isoelectronic to katong iyahang silingan ra nga noble gas. But for your metals, they will lose electrons to become isoelectronic with the previous noble gas. Like strontium, iyahang standard is Kr. Dili siya makig-isoelectronic. Dili niya dapat ipareha iyang electrons. Like barium, dili siya sa xenon. So, previous noble gas. Whereas, if we have polonium, which, hmm, hmm. Okay, whereas we have selenium, we have Se. So, Se will gain electrons to become isoelectronic with its neighbor noble gas na krypton. So, neighbor lang, pero ang metals, previous noble gases. So, natural no, ang valence electrons is 1, 2, 3, 4, 5, 6. Okay. Thank you, Aman. All right. So, thank you for being honest. Kaysa naman mag-ato-ato ta sa uban, ita magkasabot di ay. Okay. Wala na ta. So, add na to. So, we have the noble gas. Let's go back to the formal charges. Mhm. Hala, dapat mahuman nato ni. Okay, the formal charges. Okay, so dapat valence pila ka electrons kato imo na box and then minus the valence electrons. So we have that one. Now, of the two of the three, kinsa man ang gyud ang kaning most kaning contributor sa ilahang correct na structure. So we have the rule. Okay? Smaller formal charges, positive or negative, are preferable to larger ones. Okay, so we have, okay, nitrogen, carbon, and oxygen. Kinsa ang pinakadako nilang tulo? Nitrogen, carbon, oxygen. Kinsa ang pinaka nitrogen, carbon, oxygen. Kinsa ang pinakadako?
Ay, oxygen na.
As we go across the periodic table, di ba magkagagmay sila ayo? Gamay, dako-dako, dako-dako, dako-dako. Ano, di ba? As we go across the periodic table, the atomic size decreases. So, kinsa ang pinakadako nilang tulo? Carbon, nitrogen, oxygen. Carbon, next is nitrogen, then we have oxygen. Okay. So it says that in rule 1, smaller formal charge are preferable to larger ones. So smaller formal charge are preferable to larger one. Okay. We have, ang pinakadako is carbon. Siyang we have, pila yung formal charge? 0. Then, kinsay dako? 0, -1. 0. Okay, so number 1 is not, okay, structure 1 does not obey the rule 1. Because it says that ang pinakagamay nga formal charge ibutang nimo sa pinakadako sa larger one. Now, carbon is the largest among the three atoms. However, the formal charge is not the smallest ihang gibutang. Dapat anong ta siya -1. Okay, so X na imong formal imong structure 1. Now, let's go to the statement 2. The same non-zero formal charges on adjacent atoms are not preferred. So, dili pwede dapat same non-zero. Same non-zero. Okay, dapat dili pwede magtapad ang mga integers. Or, we have this one. Okay, wala man sila non-zero. Non-zero. Or we have another, this one. Avoid like charges on adjacent atoms. Okay. Number 2. Avoid charges. So it's not, dili na siya pwede sa imuhang kani sa imong statement 2. Then we have statement 3. A more negative formal charge. Okay. Now, we also have this one. Nagtapad imuhang like charges. Sumrag, ala, wala na ko ani. So, wala sa ilang duha. However, we have the third one. More negative formal charge should reside on a more electronegative atom. Now, between among carbon, nitrogen, and oxygen, kinsay pinaka-electronegative? Oxygen. So, dapat the negative, unsa to? The negative formal charge should reside on a more electronegative atom. So, dapat dito sa oxygen imuhang negative na formal charge. Okay. So, we are left with, ano no, wala na untaning structure 2 kay yatapad ang 0. However, we have yatapad man pud sila. So, ato na lang silang kuan og daog. I-break. So, we have structure 1, nitrogen has -1, whereas here, oxygen has -1. So, which is more accurate between the two? Okay, the third. It's the third because the negative charge is naa siya sa imuhang more electronegative atom. So, the overall structure, oh God. So, the overall structure of NCO minus ion still an average of the three. Okay. So, kani ang pinaka more accurate, no? However, dili pa jud siya ang pinaka-correct because still the most accurate structure of NCO minus is the average of the three. However, this structure 3 contributed most. Okay, contributed most of the most accurate structure. Siya ang pinaka dako iyang gi-contribute ba. This one, gamay lang ani, pila lang ka percent, maybe 15% iyang na-contribute. Now here also maybe maybe 30%. Then this one has contributed maybe 55%. Okay, so total of 100%. Okay, so ano siya. Now, we also have formal charge bonding electrons are shared. The formal charge of an atom may change between resonance forms. Okay, so as you can see here, we have structure 1, structure 2, structure 3, but the formal charges change. Okay, nag-change no there, +2, 0, -1. However, the oxidation number does not change. An oxidation number, bonding electrons are transferred to the more electronegative atom. The oxidation number of an atom is the same in all resonance form. As you can see, the oxidation, it doesn't change. So exceptions to the octet rule. Molecules with electron dot deficient. Okay, so we have beryllium. Okay, beryllium has only two valence electrons. Then we have the Cl. Okay, it has the Cl has only 7 valence electrons, so it can occupy only one na lang. So we have that one. So this is ano siya, exemption to the octet rule. We also have the boron. Then we have also this nitrogen. Now, as you can see here, there is another, okay, there is an add electron. So, walay pares, we have one electron. Now, we call this one free radical. Free radical. Now, if you have free radicals are very reactive. So, more react na sila, mangita pa na sila. Okay, then we also have the expanded valence shells. Now we have the phosphorus. Phosphorus and then your sulfur. Phosphorus and then your sulfur is, ano siya, has an exempted po siya sa imuhang octet rule. Phosphorus. But kani sila, wala ni sila exemption. Kani. Wala. Okay, this is exempted. So an expanded valence shell is only possible for nonmetals from period 3 or higher because these elements, okay, from period 3, 1, 2, 3. Okay, period 1, period 2, period 3, period 4, period 5, period 6, period 7. Okay, na pag-identify sa period ha. Now, period 1, 2, 3, now all kani sila na pwede na sila mag-exemption sa octet rule. Especially this fourth, 5, 6, 7 nga. Mga ginaog d orbital and then f orbitals. Okay, so it has, now as you can see here, the phosphorus has bonded to how many chlorine? P. Okay, we have 5. So the formula will be P. We only have one atom, so we don't write 1. Cl, how many? We have 5. Okay, how do we name this one? What's the name of this structure or chemical formula? We have, hala, chapter 1.
Pentachloride.
Okay, phosphorus pentacle. Okay, then we have also the sulfur. Now the sulfur has 1, 2, 3, 4, 5, 6, 6 kabukyang bonds. Okay, so they are exemptions. Okay, write a Lewis structure and identify the octet rule exception. We have SCl5. Okay, SCl5. Now, kinsa gali ang ibutan nato sa central atom here?
Lowest electron.
Okay, lowest electronegativity. Okay. Now, pwede siya kay S man gihapon. However, the exemptions, remember the exemptions, we have S and the phosphorus. So, S and P. So, pwede dyan na to nga always, here, ibutan na nato sa center ang S. Then we have Cl. Then we have F. F, F, F. Then we have F. 1, 2, 3, 4, 5, 6. Okay, 6. So we have that one. Now, what about letter B? H3PO4. Okay. Also, you draw two resonance forms and select the more important. Okay, unsaon yun ito pag-select ang more important? The formal charges. Dapat maka-obey siya sa rules sa formal charges. Okay. So, letter B, taas kaayo. Okay, kanina lang B. Letter B, no? Letter C sa letter C. So, between the, kini, sige, kinsa na exemptions aning BFCl2? Kinsa na exemptions? Boron. Okay, let's put boron at the center. Then F. Okay, then you have ClCl. We have F, and then Cl2. Okay, we have, alright. So we can have that structure. Then, okay, narang letter B, H3PO4. Okay. Okay, so this is the structure of your H3PO4. Now, which is more important? Okay, which is more important? Structure 1 or 2? Now look at the formal charges.
Ang 2, ma'am.
Okay, 2 because it can have resonance. Okay, hybrid siya, no? So the double bond can be here or can be here and double bond or can be here. So we have that one. 2 is more important. Okay, so this time, wait sa ha. Asa man to? O loko,